This panel is particularly interesting to me because all of our clients these days are showing up with big data issues. We represent probably 1,000 technology companies in the Bay Area and around the world. And I wanted to mention one in particular. I represent a company that's building schools in Kenya. And that doesn't sound like a big data play at all. But sure enough, it has become a terrific venture-funded company in Kenya that's building a school every 2 days. School in a Box, it's called. It's a company called New Globe Schools. It's a terrific company, founded by a guy named Jay Kimmelman. But they're using data from the results of each school day to change the curriculum the next day and to feed that data back into the curriculum and have directed results to the students every day. And they're charging the students $2 a month to be in these schools, very low cost. But it's just an indication of how important data is in even some of the remotest companies that we work with. So I'm a partner in the corporate group in Silicon Valley. As I said, we represent about 1,000 companies, and data is showing up, big data is showing up in all of our companies. It's a big word. When I say a big word, I mean it's a word that has a lot of meanings to it, and we'll talk a lot about that today. But before we get started, what I'd like to do is get any questions from the audience that you'd like to have addressed by the panelists today. So if there's any topics or questions, I'd love to write them down and we can address those as well as others. So is there anything that anybody in particular wants to be addressed?
Would the panel please mention any performance bottlenecks that they perceive in the processing of their big data?
Okay. Any others?
Supervised versus unsupervised.
Okay. Application you mean, or?
No, machine learning.
Okay.
Algorithms.
Any others?
Data governance for data.
How the data warehouse and ETL environments will evolve.
NoSQL versus SQL data.
What?
NoSQL against SQL.
SQL versus, NoSQL versus SQL. Any others? Okay.
What are they seeing in the healthcare area for big data?
One more.
The boundaries of big data.
Okay.
Good sign that no one's asked for where's Eric Snowden.
But you guys know. Okay, and any other questions along the way, feel free to ask them. I'd like to take questions as we go through the discussion. So why don't we start with an introduction of the panelists, and as I introduce them, I'll ask them to just say some words about their background so that we understand the context of where they fit in the big data space. So at the end, Peter Shamrock from LinkedIn, the principal data scientist at LinkedIn, and brings a terrific perspective of somebody that's actually using data to create revenue.
Hi, thanks for having me here. My background, originally I was math and physics, and jumped into a startup during that first dot-com boom. And we were focused on price optimization. So back in those days, big data was a large retailer every week shipping us a big hard drive. And I was doing some math and turning around data and giving them price recommendations on the following day. So we've come a long way in the last 13 years almost. After that, I moved into the biodefense space. and got into machine learning and sensor networks, working with lots of streaming data. And then pivoted again and went into the internet space and worked at AOL Search on large amounts of consumer internet search data, which led me to LinkedIn and DJ, who was actually my manager at LinkedIn, and got to witness the birth and development and be a key part of building the LinkedIn data team, where now I work on things like skills and endorsements and reputation at LinkedIn.
What's your education background to become a data scientist?
So my education background is I had a bachelor's in math and physics, and picked up a bit of computer science along the way, and then went back and did some graduate work in machine learning, although I don't have a PhD. So like a lot of people in Silicon Valley, bailed on that.
Thank you. Eric Balderschweiler, the CTO and co-founder of Hortonworks.
Hi. Yeah, I guess, so right now I'm the CTO of Hortonworks. Hortonworks is the largest contributor to Apache Hadoop and packages a distribution of Hadoop and its entire stack, and then we sell support and services around that. So we're sort of in the center of the Hadoop and sort of big data as a platform providing business. So looking at how I got there, back in the 90s, I was doing my PhD at Berkeley and decided that I wanted to build things instead. So I started to build search engines linked to me. To do that, you have to crawl and index the web, which is a big data problem, right? You have to discover billions of documents and process them. So we built a number of solutions to that, and then ultimately in 2005 decided we were going to build an open source solution to that so that we could put Yahoo, Inktomi was acquired by Yahoo, on the map as a place that scientists could go to work with big data. So Hadoop sort of started as a recruitment exercise. So we built that and quickly discovered that it had much broader applications beyond just building the search engine that we were working on in 2006, 7, 8. We provided it as a tool for our scientists. We expected them to get research results. That was going to be exciting. But beyond that, they started coming to us with applications and saying, you know, we can make more money for Yahoo if you can support this Hadoop application running in production every day and then every 15 minutes. So we found ourselves in the business of supporting Hadoop as a platform infrastructure, first for advertising and search in Yahoo, and then across all of Yahoo's properties. So today, Yahoo is running tens of thousands, 40,000 computers running Hadoop, and that is processing all the data behind pretty much all of Yahoo's applications. It doesn't serve the web pages, but the web pages talk to NoSQL stores. The web, the page rendering interacts with the NoSQL store that's populated with data from Hadoop. All right. So then a couple of years ago, we decided that we could spin out the Hadoop activity in Yahoo as Hortonworks. And here we are.
That's great. Ben Werther, the founder and CEO of Platfora.
Hi, everybody. So, you know, my journey to be here today. So Platfora, we build software that really layers on top of the good work that you know, Hortonworks and others do around taking that Hadoop data, the data that's landing in Hadoop, there's data reservoirs that people are building, and that's happening across you know, Fortune 500s, web, media, retail, all kinds of interesting companies, and then really providing the stack that makes it possible for regular business users to ask interesting questions, explore, derive insights without having to have the year-long IT cycles of the past to sort of leverage this data. So really democratizing access for everyday people, and allowing them to ask really interesting, powerful questions that get to, you know, beyond just slicing and dicing about, you know, user behavior and engagement and all kinds of interesting things that they might want to understand about the data that they're collecting. You know, my journey here, I was originally from Australia. I grew up in Melbourne, Australia. I came over for grad school, PhD program in computer science. All but dissertation, was persuaded to go join well, my advisor went to start a company called VMware, and then he couldn't take all of his students, and so I guess I found myself at an interesting company called There, which was a 3D virtual world company that was very interesting at the time, and I'm sure none of you have heard of it today. But then proceeded to have an interesting path. Prior to Platfora, I had ran product at a company called Greenplum, which was a big data warehousing software company that was bought by EMC, and then spent a little time helping out a company called DataStax in between. So I've been around the big data space for quite a few years now.
Thank you. DJ Patil, the resident data scientist at Greylock.
Yeah. So, good morning. And I grew up actually just down the street when this was mostly orchards down in Cupertino. And then proceeded to constantly flunk out of all my math classes. So I couldn't get into college, so I went to De Anza. Junior college, which probably most of the people know as for the Flint Center. And then finally started doing a little bit more math in the Cupertino local library. And then my doctorate's actually in mathematics, and my specialty is nonlinear dynamics and chaos theory. And I guess the thing that I'm best known for in that space is the way you currently get a bunch of your weather forecasts. It's something called the Maryland Ensemble Kalman filter technique for assessing weather reliability. And like Pete, sort of found my way into national security, working on counterterrorism and threat assessments, and then got in this weird way, turned into a diplomat and was searching for bioweapons in Central Asia and building libraries in Iraq. And my wife said, enough of that, and she said, we're trying to figure out what to do. So we picked up our bags and headed back here, and ended up working at eBay, PayPal, and Skype, rebuilding a lot of their fraud systems and that layer. And one of the recognitions at that time, I think many of us were sort of looking at the space and we're trying to figure out, how do we build these technologies faster? How do we make products on top of data faster? Particularly when you're in the security space, you're always against an adversarial opponent. And the velocity of their ability to change and adapt is always better than yours. So you're trying to figure out what these technologies are to keep you ahead. And just like the experience of Yahoo with Hadoop, we're sort of looking and realizing we don't have these things. And I remember at PayPal going in and saying, well, there's this new technology called Hadoop, and this looks like this really could get around us and do some really interesting things. And I'm like, nah, that's not so interesting, so I quit. And then went to LinkedIn, where I've been, my friend Reid Hoffman, who's a founder, we've been talking a lot about how to build the data systems a bunch more. And that this opportunity that, couldn't we actually take data and turn it into products at value add? And most people think of a data product as an infographic or something with dials and graphs. And the great thing is we already had a number of really fantastic data people at LinkedIn. Jonathan Goldman, who invented People We May Know, Steve Stegman is really kind of pushing this idea of this Who's Viewed My Profile, and Mike Greenfield, who'd done a ton of stuff. And then building that team out, we were very fortunate to get people like Pete Skumrock in. And one of the fantastic things I remember when Pete came in, he's like, well, I have this idea that you should have this idea of LinkedIn skills and you should be able to tag people. And I was like, yeah, that would be a really good idea. You should go do that. And so, Pete is the genesis, actually, of this whole idea of that LinkedIn skills and endorsement. So if you don't like it, you can blame Pete or endorse him. Says payback, everyone should go endorse Pete.
Endorsement for payback.
Exactly. And from there, LinkedIn has kind of become this place where we've had to invent a lot of technology in that process. And so we're really looking at saying, okay, this product doesn't work unless we build these new technologies. Kafka, Voldemort, all these other systems. And a large part, even working with Ben and sort of getting a lot of advice from the folks in the community, we sort of realized, wait a second, we have to, with this industry, we just don't have the right tools, and we need a whole new way and paradigm of thinking about these things, and a whole set of people that need different types of training to go after this space. And I think now what we're seeing, especially from being at Greylock, there's a question about what can we do in healthcare and these type of things. And I think we're now starting to get there where people across every vertical are recognizing, hey, wait a second, data has to be a competitive moat. If you want to compete, how are you going to use data to stay relevant? And that's been the interesting shift over the last, I'd say decade, if not 20 years, as a reinvention of a field that's existed before, but a new take on it now.
That's great, thank you very much. So let's add some additional context to this. The whole big data space is a word that's used, and it's a very broad word. Let's maybe fill in the stack a little bit in terms of where the companies fit and what we're really talking about here. I'm probably the least technical, but let me try to squeeze it in here. So I'm guessing that down here, Ben, I don't know which level is appropriate, but you guys are sort of the base level.
I mean, Hadoop might be the lowest level infrastructure.
Yeah, I'm sorry.
So it would be more Hortonworks and.
Yeah. So.
Actually, I think you can argue there's two paradigms here. So one is infrastructure stack and application stack. Because on like one very low level, you'd say, hey, look, I need to process data. The other is I got to collect data. And then you have companies, I think I saw someone here from Sumo Logic, which is like this company where you're actually taking in this machine log layer data and then you have to transform it. But you need those collectors and actually have to transform it. And then you've got to use these other these important systems like Hadoop to actually do stuff. But on the flip side, you also have to move that data around. And so we have a lot of complexity, I would argue, in the stack. And that's one of the challenges of trying to think about it that way.
So Eric, we put Hortonworks down here.
Sure. I mean, I think that makes sense. I mean, there's two ways to slice
Actually,
it.
do you want to take the pen and break this down?
I think you're doing a fine job.
All right.
But let me,
everybody can read that Horton down.
but I think there's kind of two ways of slicing it. One is what activity, right? So there's sort of, let's call it backstage and front stage, right? When you ask about NoSQL, for example, most of that is sort of what I would call on stage, where you're building an application, you're interacting with users, you want low latency activities. So that's kind of, how do I build an interactive application? So then you see all your NoSQL technologies, then work with data stacks, work in some of that. Then you've got your sort of data processing back-end systems, and that's where you'll see Hadoop. Not perfect, but that's kind of how I would divide it in terms of kinds of activity. And then when you look at backstage where I live, we've got sort of, first you have to sort of just collect the data. I mean, if you look at the adoption of Hadoop, we see sort of three phases. First, you'll see sort of a cost reduction process. Let's store the data for less, let's put it in Hadoop. Or let's do ETL for less, let's use Hadoop because it's open source, it's free, more free, and we can save money by deploying Hadoop. But then people start manipulating the data, right? They want to investigate the data, have discoveries, drive their business, right? So BI technologies, things like that. That would be kind of the next level of adoption, right? Now I'm not just cost reducing in a vertical, I'm collecting all my data together into a new kind of data repository, a data lake. And I'm trying to make sure that I can interrogate that data, find data discoveries. And then kind of the final stage is applications, right? How do I start actually building new big data-based applications? So for example, at Yahoo, the sort of core application was first web search. How do we sort of index the web and serve it? And then how do we serve advertisements, right? So that's where you see the data come into Hadoop, get processed, so that we now know what every user in the world's interests are. We put that into a NoSQL store, and every time they visit, we use their interests to select the best ad. So that's sort of stage 3 is applications. And
yeah, just to chime in, I think that's a pretty accurate representation of divide and conquer the big data space and the stack. I think the interesting thing DJ might have been alluding to is that when you're in that top layer, there's this feedback loop where all these things have to work with each other and inform each other. So if you're building, for example, at LinkedIn, if you're building something like LinkedIn skills or endorsements, where we're suggesting skills you might want to add to your profile or people you may want to endorse, that product then has to feed back into that lower layer. And people who are coming up with products like that, data scientists who are digging into the data, may have ideas to change the product, so they have to be able to inform, they have to be able to look at that low-level data and say, hey, maybe you should change this product feature up at the top layer. So I think one of the things that you're seeing is like, it may make sense to divide these things logically and say, okay, here's this low level stack, and I can have a team doing this, and I have a team doing this, but you do need some continuity and somebody who can see across the entire, cut through all the layers, and you need people from the bottom to be able to impact things at the top layer, because otherwise you'll get, like in supply chain, you get these like whiplash effects, right? So you need these layers to be able to influence and interact with each other as well.
Yeah, I think we, sometimes some of you guys may have seen these charts, industry charts of all the different companies in the space, and you can find a big data one that has like 300 companies on it, and sometimes we have somebody will say, well, how are you different than all these other companies? And I think that at some level, I think it boils down to Eric's description, which is there's a core thread I think that carries through this, at least for enterprise customers, which basically boils down to, I've got lots of data being generated across my company. I want to be able to collect it, I want to feed it somewhere, I want to be able to store it, and then I want to be able to understand what I have, and I want to be able to enable useful things against that it can involve different types of exploration, analysis, machine learning, and so on. So in there's a set of companies that may be involved in that stream of stuff, and then there's a whole lot of almost like micro optimizations around that. You have all these like, the cool things like streaming, Storm, and some of the things that are about real-time event type things, or this complex event processing type of things that people are adding on that are great. If I know there's some particular thing that I found that I want to now instrument and have a view into in real time, I can go do that, but that's kind of a second or third order thing after you've kind of got that core thing figured out. And so I think focusing on what is the essential core of this, and then there are obviously tons of offshoot things you might want to do, but most of those companies are solving, honestly, the niche sidelines rather than the essence of the core problem.
And is LinkedIn a potential customer for you guys? I imagine it is, right?
Yeah, absolutely. I mean, they use Hadoop. They have great internal capabilities, but we do some things that no company does internally that would be valuable to them, and we know the team over there pretty well, so they're obviously ongoing conversations.
And Peter, you said you guys have built a lot of these products yourself. Is that fairly typical? And where in here have you built it? Everything above Hortonworks?
Well, I think we're kind of partners and contributors to a lot of open source projects, and a few that DJ mentioned, like Kafka, Voldemort. We have a number of technologies that are open source that also, usually Apache projects that came out of LinkedIn. I think that the Valley is a little bit unique, and sometimes it's good to step out of the Valley and think about larger enterprises that don't have 50 or 100 data scientists and core committers to Hadoop. I think that it's I think there's a unique set of companies here in the Valley that employ 4,000 or 5,000 plus people. That's an environment which is difficult to replicate in the rest of the country or rest of the world. And so I wouldn't necessarily recommend every company go do that. It may not be a core competency for what you're doing.
Go ahead, Eric.
Yeah, I would kind of second that and say, I think when you ask where is the sort of entrepreneurial opportunity here, right? I think that if you look at the companies we work with, what you see is across the world, and pretty much every vertical, there's somebody with enough critical mass and sort of technical focus that they'll go and build a data science team and be able to sort of lead, right? And in pretty much every vertical we see this, right? There's, we're working with some folks in the retail space who, built their own sort of cloud before clouds existed, and they're perfect. They've got data science teams. They're building their own sort of golden record model of a customer across all their activities using Hadoop and Cassandra. So they exist. But then there's everybody else in that space. And they're looking to solve all the classic problems, and they'd like to work with toolsmiths who can give them sort of packaged product to solve specific vertical problems. Right? So I think that's a pattern where, how do we, at the platform layer, the base technologies are maturing pretty fast, right? The sort of Hadoop Hortonworks layer. Then there are these data tools, ETL tools, motion tools, things like what Ben's building. But then on the vertical applications, it's wide open. It's so early. And I think for every market, there's a need to combine an understanding of these big data technologies and the science and that specific market's problem.
So do you think the reality is out there that there's a lot of infrastructure that's been built, but the companies are really at the beginning of being able to actually take advantage of it?
Oh, absolutely. And like I said, there's sort of 3 phases of adoption, right? You can bring in Hadoop as a cost reduction effort and have tremendous success. And if that's your definition, I'd say Hadoop's crossed the chasm of being widely deployed across the Fortune 500 and beyond. Right? But if the question is how many people have sort of reached this, interactive applications based on big data, yeah, it's much earlier, right? And companies need help.
And
I
Ben,
think it really depends on the scale and scope of your company too. If you're talking, so one thing I think is also useful is to ask, what is your goal that you're really trying to do to accomplish? What are you trying to accomplish by using data? In one area I'd call it decision sciences, which is a different form of, or an advanced form I'd call it business intelligence, where you're really trying to figure out should you turn left or right at the fork. You're trying to inform business decisions. Another would be data engineering, data operations. How do you move the data around? How do you get it to some type of customer in the right time period? Another would be data products. How do you actually add value with data products? There's data marketing at this point, where you're using data to be much more effective with marketing. And there's data sales, even data customer service at this point. And so you have to, in deciding what you're trying to do, so there's a ton of places where if you're trying to build a data product and you're trying to build it on top of Hadoop, you're crazy. That's just stupid. Let's just call it like it is. It's just a terrible idea for certain things. For a lot of other things, it's an awesome, perfectly brilliant solution. If you're trying to do a ton of stuff where you're trying to do a lot of decision sciences, and you're going to say, oh yeah, you should write this all in Hadoop, and you're going to ask somebody to do a query language on it, that's also insane. What you should be, and if you're trying to do a bunch of dashboarding and everything, maybe you should be using Platfora instead, because you don't have the skill sets locally. So it's really a combination of the question of how do you find the right bridge and the right medium between the type of personnel you have and the type of goals that you're trying to accomplish.
I think also, most enterprises are just beginning to figure this out. So I was at a briefing yesterday, and there was this conversation about data, big data as a boardroom discussion. And the amazing thing is now, across Fortune 500 and across large companies, the board is saying to the company, to the executives, what is your big data strategy?
I call that winning. That's winning.
Yeah, well, but it starts with, it can start with the blue ribbon committee of people going, what is big data, but there is a certain amount of this is top of mind, and, the problem with, the good and the bad of that being so top of mind is, it doesn't start with one narrow use case and a quick win. It's sort of, what's our big data strategy? And I think the other thing that people observe very quickly is, okay, well, if the aspiration is things like I want 360-degree view of a customer across every interaction across a bank or something like that, the first thing you need to do is start to collect the data and put it in one place and begin to build this sort of reservoir or a lake, whatever you call it, that will enable that kind of analysis. And so there's a certain leap of faith that people have to take where, the approach DJ describes where you start with the end in mind is ideal, but there's no way they can do that. So it becomes I have to take a leap of faith of storing the data with the idea that there's going to be good use cases, and maybe there's some quick wins, hopefully you have in mind at the beginning. But most of that is faith that the journey, 1 quarter, 2 quarters, a year out and beyond, is going to be better because I captured this raw material for my business.
Could I chime in for a second? I agree with you. I think the thing that I'm starting to think about and pick up on is that it's no longer about making the case for big data. If you have to make the case for big data in your company, I think you're actually behind the curve, right? And you're in trouble.
You should leave.
Yeah, you should probably leave. And here's the other interesting trend to think about. So before it was, okay, big data is going to be your competitive advantage. Now if you're not doing it, you're left behind, right? You're already done. And as an example, I think if you look at web apps and the Web 2.0 and the consumerization of the enterprise, that's this other big trend where people use all these great internet services like Google and Twitter and LinkedIn, and they're used to these experiences and they're used to that pace of innovation. And when it comes to other enterprises, like look at your car, for example, right? And like Tesla now is embedding all these great product experiences into an automobile, which hasn't changed in like 50 years, right? And I drive Toyota, so I opted for that a Camry instead of the Tesla. But my GPS, I start typing LO, and I'm thinking like Los Altos. It doesn't know enough about where I am to say Los Angeles. It's saying, okay, you're going to Los Angeles. No, I've typed this in 50 times. Why don't you know that, right? And so you get frustrated with these kinds of experiences and interactions because you expect technology to adapt and react to you at a pace that requires all that data processing, big data. And the companies, Tesla can figure that out maybe, but Toyota can't. Are they going to be there in 10 years? We'll see.
This sounds like a services dream for Accenture and McKinsey and all those guys. Is that fair? But Ben, are you guys providing services, or are you bringing in services?
It's very, very topical because our initial intention was to not be in the services game, and now I think we realize we have to be in just a little bit. I think it is and it isn't. I mean, there are some companies that have done very well being very services heavy around big data. Companies like Opera Software and others that have lots of really smart people, and you can sort of pay to have them engage around problems. I do think that there's this analogy I've sometimes talked about around the idea that we're sort of in the imagine the days before you had mass produced any products. You had everything was bespoke, custom engineered, and so we're in this age right now where if you want to do the most interesting things, it's all custom development. You go find somebody who's skilled in it, and they go and construct you a custom solution around that, and it's the one of a kind type thing. And we're beginning to enter the age where there's a certain amount of productization and mass production that says more and more of that pie is going to be leveraged products that you can cost effectively deploy. And so, I don't think the answer. I think today there's a growing market and there's a lot of services, but as the market grows more, part of allowing it to grow more is the proportion of services has to shrink, and the proportion of product and things that you can get quick value from has to increase. And I think that's the natural way it has to work.
But we're not there yet, is my guess.
It's in that transition phase. Early.
Yeah, I would second that. Like I said, I think there's a great entrepreneurial activity in sort of figuring out how to package solutions around big data to accelerate the company's adoption of it. Because right now you either need to build, specialized staff, and you can build and train and hire for that, but it depends how high up that pyramid you want to go and the complexity of the applications you want to build. At some point, most companies find that they're bringing in SIs to help. And we'd like to see the market mature because it's not our aspiration to be a services company either. But we're in a phase where we're doing about a third services just because it's that's the hook that brings in a lot of sort of support revenue down the pipe, right? Because you need to get the applications working in the enterprise so that they can then deploy more widely.
Question.
So you've mentioned advertising as one of the very first big applications and revenue generators. Could you mention which other vertical industries, since you've described that model, where are you seeing adoption for things other than advertising? Actually, that they're getting revenue from as opposed to just experimenting and feeling their way.
Sure. First of all, it's very widely used just for data management, cost reduction there. So, as I said, sort of the first phase you see is cost reduction, and that works pretty much across all industries where you're dealing with large amounts of data. Certainly financial is using it a lot in a lot of number of applications, both sort of banking, trading sorts of applications, value at risk computations, things like that, fraud detection across many activities. Those are early adopters. We're seeing it in utilities, network management. We're seeing it in telcos, things like that. There's just anybody who's managing a large network, many interactions. You can DJ can probably chime in. Ben. Yeah.
Go ahead.
I think you're seeing. I think there are certain use cases that are simple use cases you're seeing in those companies that are doing, like telcos and sort of infrastructure, companies like Backspace and others that have infrastructure. They're using some of this stuff for doing analysis. You're seeing obviously in the news recently, in the federal space, there's certain usage. I think that overall, there was a good question about, in some ways, I think about it as a journey a little bit like virtualization, where VMware at the beginning, it was clear that there was going to be this. It was clear that people close to it, there was going to be this vision of sort of this dynamic data center and dynamic provisioning, but the early use cases were all around, lower cost, like saving money on doing testing and doing very sort of quick deployment, and it was all of the low TCO benefit at the beginning, and then it became a agility and sort of an optimization and better quality of service play over time. I think what we're seeing here is it starts out with most cases as being about not throwing away the data, which is a key imperative, and then lower cost of ownership around, it's more than just like saving money. Like you literally could not afford to keep the data on the older infrastructure. So it's like you're throwing away your raw material that's going to be the future of your business if you don't have that opportunity. And then there's, but then I think the kind of cascade of use cases and the value up is everybody's pretty early, apart from people who've sort of invested heavily in kind of specific algorithms or applications, search engines or multi-color simulation and stuff like that they've been doing for a while.
Yeah, one way to think about this, I think is we've also had like a lot of these traditional companies, and take advertising and that world itself. I think that a lot of those companies are ripe for disruption with completely new approaches on how to think about it. One of my favorite examples, I think I saw the CEO somewhere here, Chaitanya, and founder of Insight Vault. And these guys are doing this kind of crazy new way of thinking about this whole space and really approaching it from a very fresh look, very data-centric. And you sort of think, well, wait, advertising has already had this very data-centric view already, but they've decided that the knob can go to 11. And it's this whole new approach. On the totally other side of it, we have GE diving all in on the Internet of Things. We've got the Nest and all this sort of quantified self. And so we're seeing this whole paradigm where someone says, I bet we could make the life a hell of a lot better by using data. And so the product competitive advantage to achieve the goal is through data. And that's the transformation where we're seeing people saying that. How many people here are actually consider themselves working at a data company at this point? So not a bad result. Well, maybe we're biased here because it's a data session. But you get that sense, like especially as you see stuff, especially coming through the door of Greylock, things are very heavily dialed towards some element of using data creatively, and that's the key word, is doing things in a creative fashion.
Yeah, I think Ben, you said a couple times this point about not throwing your data away, and that might have kind of not sunk in, but that is a huge deal. When you deal with even when you have a large scale like LinkedIn, there's constant discussions about, okay, well, how much of this data do we need, and what are you going to use it for, and do we keep this feature in the product? Do we keep using this data? And I think that's even a challenge for us with it, internally, to communicate as data scientists. Okay, yes, this data is really important because the creatives who are digging into that data may have some idea or vision of, hey, we could use this to build X or Y. But if they're up at the top of that chain and not down at the bottom, deciding, okay, what data do we keep? You really need that kind of connective tissue throughout the company so that people over in Department X can influence, Department Y who's keeping and collecting that data. The analogy, there's these quotes that always flow around about data, like, data is the oil of the information age, right? Well, think about it this way. If data is the oil of the information age, is your company just throwing away barrels and barrels of oil every day, right? And that you could use, 20 years down the line when you invent, engines.
Yeah.
Right?
The one thing I'd add is, we always, as vendors, talk about these kind of vertical applications, right? Yes, if you're in the, fraud management business, then, clearly fraud's a big data problem. But the thing I would add is just that every organization deals with lots of data problems, right? So, communication, customer management, marketing, building websites, all of these are data-centric activities. So we're seeing Hadoop used in sort of across, every organization has many potential applications for big data as you scale the organization or your customer base.
It's great. Question here?
Yeah, it was a question related to boundaries. As we see, we work with many Fortune 100 companies for which the term big data is not really applied. Let's say about customer 360. We have clients that have like 50, 60, 70 million clients. They do 360, and for them it's still not big data. We're talking about major retailers. They're impacting every item on every cash register on every store. They still don't see that as big data. So when should the shift happen? When company knows that, oh yeah, we should change the paradigm and look at it as big data?
I suspect in those cases, if you thought about every touch point and every event generated. I'm sorry, the question was for large Fortune 100s, when is it big data, and what's the line where it becomes big data when they're not? Yeah. I think that first of all, I mean, they probably have big MPP databases, like big parallel databases, and are doing things that are kind of generally of that. They involve a lot of data. But I do think that there's two things that I think change that my suggestion, the hint that they're not there yet, which by my definition, which is one is if you think of every touch point that a customer has with one of these companies, so websites, every event generated, every observation around the way they interact, like if you're a consumer goods company, what environmental things about temperature and other things that were relevant, that might be relevant to why people bought your product, or these event streams are often very, very large. Generally, they're not being stored, or they'll say, well, we're collecting 360 degree view of a customer, and you say, what about like clickstream? Like, oh, well, that's a different thing. We put that over there. That's not part of the analysis. It's not part of the picture. And there's all these other data sets that they don't consider part of customer 360. Although, if you think about it, those are the most essential events related to engagement of the company with the brand, or with those consumers with that company.
And with data, it may give you a lot more insight, because this is often when you're developing a product or getting feedback, you ask people. I was at a small startup in DC, and we would call these potential customers or clients that we had and ask them, hey, we have this idea, can you give us your feedback? They don't want to hurt your feelings, and so they tell you what they think you want to hear. The data doesn't lie in that case, right? And what people say they want versus what they actually want are often two very different things.
Yeah, I would just add, a lot of this is sort of state versus history, right? Your current account balance is a small amount of data, right? But looking at every interaction you've had at the bank, that's a much larger amount of data. And so it's switching that lens to everything that's happening.
And I think that for me, that the litmus test of in the old world or the new world is there's probably a list of questions that they built their data warehouse to answer, a set of key metrics and reports and so on. So if somebody comes along and says, I've got this idea that there may be this connection in our business that involves, let's say, in the banking context, risk and our marketing upsell opportunities that span the business. What's involved in being able to answer that question? Is it a 1.5 year long organization-wide initiative, or is it somebody sitting down and asking a question of some data? And I think that if you have to do the work to be in a position where that's a fluid, democratized thing that somebody can do, and it isn't a 1.5 year long IT project for 50 people.
So one of the verticals that you haven't discussed is health information systems, which has a very antiquated core, but is probably the biggest impact to society. Can you talk about how big data is going to help?
Sure. You put it very politely that the healthcare system is antiquated. I'll try to keep it not profane. Talk about these systems are ridiculous at this point. You've got a few major players. The data is not interoperable. You can't move data around. You can't blend it, and and then we throw up all these reasons to say no rather than reasons to say yes. And the biggest one is HIPAA. And so everyone's like, oh, well, that's not HIPAA. So I actually started to become HIPAA certified, just so people would be like, no, that's not true. and I think what we have to adopt in this stance is, into this argument of even bringing data together to do something collectively, it's horrible how tough it is. We also have an issue of time scale on what the data is. There's, on one side of things, people want this very high-speed quantified self stuff, where you're measuring yourself every day, and then there's other things that don't change. Like if you measure your weight every 10 seconds, that's not useful data. But measuring it once a day or once a week, those can be much more of a useful signal. And so in the healthcare, I think the thing that I found where people are getting the biggest bang for the buck is to go, and if anybody who wants to work on this problem, the number one thing I encourage you to do is shadow a physician for a couple days. Just follow them around. In fact, if you're just even in UX and UI, follow a physician around, and you will go insane at like looking at their technology. Your eyes will bleed after an hour. It is so badly designed. And it's like the antithesis of Apple. It's just, and what I would encourage people to do is look and follow and do that ride-along model, and then ask yourself, how can I make this person's life better in a very simple way? What little frictions can I take out? And if you can bring some data elements together to do that, and we're seeing people starting to get there. 16 months ago, 24 months ago, not even possible. Now it's starting to happen. And if you can work with them, it's great. If you're able to work outside the US, even better, particularly with the UK and in India, you actually have a really good opportunity to actually bring data together in a unified way to actually attack problems. But one of the things that we have to start pushing for is much better transparency in the medical establishments to actually get access to this data.
I think, DJ, I know you spent a lot of time thinking about this space and done a lot of great work with nonprofits in that area. And I can't echo enough, like, this is one of those tough areas where I think you have a kind of government and kind of entrenched players who are very hard to disrupt, right? So I think a lot of things in Silicon Valley, you tend to go towards like the low friction startups or areas where it's open, where you make a difference. When you hit up against, like you said, HIPAA, these other things, it makes it really tough. I think it may be a little time before the data startups really penetrate deeply, just because there are these barriers to entry that are difficult to overcome. But if you were looking at a real low-hanging fruit, how many times do you go to a doctor's office and fill out that same form, saying your name, your address, your past medical history? I think it's like almost every visit or every new person that you see. Think about the time wasted, both for you and then the person who transcribes that and enters it into a system. That's huge, right?
Oh, for Ben and others. We've been talking about other sort of industries that have been slow to adopt some of these new technologies. You have tech and financial services way out in front of do. And then you have the other industries that have spent a lot on data warehouses and Teradata, like oil and gas, consumer, autos, you name it. What's kind of the gating factor? I mean, it seems like Platfora is saying if BI becomes self-service, that'll pull this forward. What are kind of the gating factors on those other industries taking the leap?
Yeah, so the question is, for everybody, there are some industries where people are ahead using these new big data technologies. Many of the more traditional ones are still heavily using traditional data warehousing, ETL, these sort of the traditional ways of doing this, and they're further behind, and what's going to bring them forward and get them into this new world. I think that for one, I think there is actually a surprising adoption of Hadoop technology. You go to insurance companies in the Midwest, some of these companies, there are amazing places where this stuff's popping up. A funny story I heard of, so there's a medium-sized bank big bank in Utah, Zion's Bank Corporation, and at Greenplum, we sold them a data warehouse, and they had this 20 terabyte data warehouse there, relatively small, but they were a big evangelist for what we did, and I was talking to them a little bit after we started Platfora, and they said, one of the guys said, it's kind of amazing, we've been talking about this data warehouse all this time. I just discovered down the hall, there's this like 5 guys who put up a Hadoop cluster, and it's 200 terabytes already, and they're doing real work, and nobody even knew this thing was there until like 2 weeks ago. So this stuff is popping up everywhere. It's just not always in part of the enterprise infrastructure yet. But I do think that the bigger gap is like people need the business value path to be clearer in a lot of these cases, and potentially some of these vertical solutions. They're not going to roll up their sleeves and take a training course and start developing from scratch. They want to be able to have the ability to just get going and have a path to value that's a quarter. And I think we're getting closer to that, and I think it's going to get easier. I mean, we're obviously playing our role, but I think that collectively they just can't afford to be bleeding edge inventing this stuff in a lot of this. A lot of the industries you mentioned, like oil and gas, actually are using a lot of Hadoop. But there's some of the more traditional. If I'm a regional car auto distributor, I don't know if I'm using it today, but I probably some things have to happen to make it easy enough and interesting enough for me to be there.
I would just add that we have engagements with every kind of industry you mentioned, and I mean you see two things. I would second what Ben said, that in companies that have sort of knowledge workers and departments, we see lots of department level Hadoop activity and sort of focused solutions. But also, I mean, Teradata is a big partner of ours, right? And we sell Hadoop with them, and we see a lot of people, like I said, doing complementary things, right? We don't anticipate, I anticipate that there's going to be more data warehouse technology deployed in 10 years than there is today. I just anticipate that as a percentage of your floor space, big data and cloud are going to completely dominate in most organizations. But that doesn't mean that they're going to rip out all of their existing data architecture. Those are applications they've spent huge amounts of money that are solving real problems. So what we see is Hadoop coming in and capturing that data and then combining that with other data. So you see Hadoop moving in for ETL, retention, right, and archival sorts of applications where if we used to, a lot of organizations are bringing Hadoop because their warehouse maybe has 90 days of data or a year of data, and then they put it, on tape. Now a lot of people are bringing 7 years of tape back in-house, and so that's a complementary use case. And then they combine that with social data, log data. So like I would say, I think the two technologies actually are very complementary, and we're going to see more of that.
I don't have to be quite as careful about. I do think that the Teradata and the others, they're going to continue to grow, but in the same way that mainframe technology continues to grow, it's something you don't decommission, you leave it in the corner, you don't touch it. That there are a lot of the more you see people moving to reducing their investment there so they can have agility around the newer questions.
Like a near term driver of that?
I mean, I think there's classes of technologies that are making providing easier access, like Stinger and Impala to Hadoop data. I think there's one class of thing, but I don't think that doesn't make Hadoop a Teradata data warehouse. I think it's a longer conversation, but I do think it's at the end of the day, the things you need are those expensive data warehouses for getting more and more narrow. I'd say that.
Do you guys provide SaaS versions of this or not at this point? I mean, is Hortonworks a SaaS product, or is that just infrastructure and can't be done?
So, I mean, SaaS is a company with a product that is working with Hadoop vendors, including Hortonworks. Software as a service, yeah. It is available. It's available as a cloud service from a number of providers. We work with Rackspace and Microsoft. It's also available from Amazon, sort of.
Or is it too complicated to be sort of put into that format? Maybe Ben. Maybe it's
from our side, we sell software. I think it's a decision because most of our customers want to run it, have a choice of where they run it. Like the cloud is a great thing, but the data has weight, and the data goes where it's most convenient, and that may be the cloud if you generate it in the cloud. Often it's still, for a bunch of reasons, behind the firewall, and so we don't prescribe one way or the other. But we have customers who run our stuff in the cloud. They're running software. We're not hosting it for them. We could go down that model. It just hasn't been.
Well, one great example, I think, of people who are moving lots of data over the wire in a cloud solution is Sumo Logic. So you're doing machine log layer stuff, which is a ton of data, and it's all in the cloud service. So I think we are seeing a shift that's starting to happen.
Yeah, I think it depends where the data is generated. So with these new services, if you're logging and these events are happening with some partner who is then logging that data to the cloud or to EC2 or something, or S3, then running Hadoop where the data is I think what it's all about. If you have your own data centers, then the cost question becomes a little different.
Yeah, I would just add that many software as a service applications have Hadoop as part of their backend. So I think anybody who's consuming SaaS is probably consuming Hadoop somewhere.
Yeah, right. There's a question back here.
Yes, Eric, can you talk about building a company on top of open source and sort of how do you differentiate?
Sure. How do you differentiate if you're building a company on top of open source? It's certainly something that we've thought a lot about, although I'm sure it varies a lot by market. But so if you look at Hortonworks, right, we provide a Hadoop distribution. There's several other companies that do the same thing. But so we looked at that and said, well, this is, Hadoop is a data problem, right? So ultimately, when you come to a software provider, you're buying insurance at the end of the day, right? If you're dealing with open source, anybody can in principle install it. But what you want is to be able to have contact with the experts. So when we talk about Hortonworks, we sort of have two pillars of differentiation. One is we have the experts, right? We have the folks that built Hadoop since its beginning, right? Doug and I negotiated, exactly how Hadoop became Hadoop, and then, we built a team at Yahoo that took it from a prototype to what it is. But so our strategy is, differentiate by having the knowledge. And that means that when we form a partnership with a Microsoft or Teradata or Rackspace or a number of other partners, what we can offer them is the ability to evolve the technology to interface with their technology. So that is why partners work with us, right? When we look at customers, they look to us because, again, we have the guys that are responding to the bugs, right? They see in the public record that when something goes wrong, we're the folks that actually fix it. So expertise is one pillar of differentiation. So our other pillar is complete openness. What we say is when you're coming to Hadoop, you're looking to move out of a lock-in situation into an open source situation. So we differentiate by being the only company whose product is completely free. Now, that's a fairly unique approach, and it's working for us. But I think that you've really got to look at your market and your strategy. But I really like it in our case, and we're getting really positive feedback on the hypothesis that you can do that.
And your revenue model, how would you describe your revenue model?
Our revenue model is a support model. We sell, the majority of our revenue is directly from selling support contracts on an annual basis, right? You have the right to pick up the phone, call us, and have us help you resolve cases in production or during development. We also, of course, provide training and consulting, which are great lead generators, but the core of our business is support.
Yeah. The other aspect, we see there are more opportunities than people to solve some of them. Startups are finding it difficult to get normal programmers, later on people who could design and create new systems. So there's, you mentioned about Accenture as a service provider. There are large IBMs and Accentures are there. They're enterprise customers globally, but they're not getting the talent, and they don't want to take the package software and implement it. So any solutions of how to build the talent shortage and the need globally? You mentioned what you do with healthcare.
Yeah, so I actually happen to be wearing their shirt today. This is Inside Data Science Fellowship Program, and a bunch of the people here have also helped out with that. And what we do is we take people who have, right now it's currently only people who have gotten their PhDs, but do not want to enter academia. They come out for a couple weeks, they train up through a curriculum, and they pay nothing, and then they are inserted into a number of the top companies out here. You can just go through the roster. And part of that feeling is there's a lot of people who are trying to create data science programs and curriculum, but they're not hands-on enough to insert you into knowing how to actually deploy production. And Pete and I have had our fair share of bringing in people from the academic realm and then realizing how long it takes to ramp them up to get them even ready to do something in a real company. And it's just a different cadence. So that's been one of our that's a very high level, very type, you're creating like the super elite data scientists of that tier. For the other tiers, I think there's a lot that academia is actually filling in, and I think there's a ton more we're gonna see in the massively online courses. And then we'll have the services that are gonna pick up a bunch of the other stuff as well. And there's many more of these that are coming up all the time.
I agree with all of that. I would add, I mean, obviously, right, I mean, one of the problems is a data scientist is an elusive beast, right? It's a hard thing to find.
There's one sitting right next to you.
Yes, I'm surrounded by them, but that's privileged company. But one of the things that sort of we've observed and learned is that big data projects are team projects, right? So a lot of times, if you stop thinking, I want to find the one guy who's got all of this in his head, I mean, there are not a lot of them, but it's easier to find statisticians and programmers and put them together on teams to solve problems, right? So that's something that we have found some success with. And of course, there's training from multiple providers, including Hortonworks.
Yeah, I think there was a great talk. I think it was John Rouser he was at Amazon. I think he might be at Pinterest now or somewhere. But it's online. It's from Velocity Conf a couple of years ago, and he gives a great talk on this question of like what is data science and how do people get there. And there's this great I know people from Accenture love these like quadrant charts and. And you can think about it, like there's a whole bunch of different skills. One of the big chunks is this domain knowledge, and you talk about like specific verticals that you're in. But the core skills really do come from the computer science realm and the statistics and math and hard sciences. And so I think the trajectory that we see is usually one of two things. One, you start in that sciences trajectory, which is like Insight Fellows takes people from that quadrant, and then tries to shore up their engineering and their programming abilities enough to make them dangerous. And then over time, you follow that path and you end up hopefully in the upper right quadrant. On the other axis, you have people coming from a computer science background and maybe doing some machine learning, and then you can take people from engineering and they're interested in machine learning and they're interested in statistics and model building, and they gain those skills over time. So I think that's probably the best way. Over time, as our team has grown, we've had to adapt and we've had to take people from slightly different backgrounds and grow and train them.
Yeah, I think the other thing is I think it's useful to think about just the spectrum of how unevenly these skills are sort of spread around the world. I mean, I think of the analogy, if you think of like crawl, walk, run to like elite basketball team, like you're talking about elite basketball team on one end, and the vast majority of the world isn't even a crawl, they're still on the couch, right? So it's, so you don't have to go that far. Like a lot of, I mean, like this briefing I was in yesterday, this company that was on the couch wanted to know how in one step can they become an elite basketball team, and it's just that's unrealistic. You just don't do that. And so first of it is there are problems that are real data science problems, but there's a wide sort of things which are really more about just access democratization and enabling average business users or analysts to ask simple questions and build intuition against data and iterate and learn and see what they can come up with for the business. There are definitely classes of things that involve statistical questions and building data products and so on, but I do think that so much, anything that is new becomes sort of data, is often lumped as data science, and I think it makes it all sound sort of magical and like you need this magical skill set where I think better tools and just building the basic competency goes a long way, and I think that's how most of the world is going to have to, get better at this.
I think 80% of the value often comes from very simple things, either simple models. You can look at, there's all these more data beats better algorithms, and Peter Norvig at Google gives some great talks on that subject if you want to look up more on that. And I think the challenge is like everybody. Even if you have a problem that only requires someone with like a high school degree to solve, people will want to hire a PhD, right? Because why? The insurance. It's kind of like with the open source company. You want to make sure that, hey, this plane is not going to crash, right? So put your best guy on it, right? So I think that some of the shortage is maybe a little artificial in that sense, in that the bar is really high and you don't want somebody screwing up your medical data or whatever. And so that, industry is going to have to deal with that. And I think you have to look intelligently at your problem space and what you're dealing with. and be realistic about, well, we have a Class A application, Class B, Class C. Class C, maybe I don't need my PhD neuroscientist, rocket surgeon on the problem, right?
Yeah, one thing that I encourage all of you that are going into, if you're having to justify sort of how you think about the allocation of data or data people working on things, data science is a team sport. And you know, I've talked to several hundred companies over the last 2 years and trying to help them out. The one thing I always tell them is data science is a team sport, right up on top of the board.
TJ, what about the venture community, based on all we've talked about? Where are the opportunities? What are you focused on at this point?
I think there's a couple bets. One is the infrastructure stack and the pieces to make data more effective. There's people who are building products where data is a competitive angle, and then there's also the verticalization. The part that I think is the most appealing to me personally is how do we make superpowers for people and use data to do that? And so what do I mean by that is a superpower is something where, take the first time you see a Google map, or it's a Google map on your phone, and you're like, wow, this is amazing. And now if I take it away, you're like, I'm literally lost. That kind of feeling of those, that kind of empower, and that somebody really loves your product and gets it and understands it in the first 15 seconds, and that wow factor, people may know is a great example of this. It's like, how'd you guys do that? This adds a ton of value. Any product that is of that nature and does that, I think has an immediate ability to differentiate itself and either grow virally and cover a great amount of distance if it's a consumer product. If it's an enterprise product, it just adds, we're seeing this complete reinvention across the enterprise space. Take Workday, for example, which is about $9 to $10 billion company. You've got LinkedIn, that's this sort of wild success story. And you just kind of go across the whole realm there. Everyone's trying to reinvent that space, and the number one way they're doing that is through data. And I think that's what's exciting everybody around that, and that's what's saying everyone's driving additional investment into the infrastructure stack, is saying, hey, you can't do this unless we have better solutions up and down this problem, because otherwise you're going to spend 2 years engineering probably several hundred man hours just to build that infrastructure otherwise, and that's crazy on a burn rate perspective.
The question here is now Hadoop seems to be a good car, a good workhorse. Anyone is not driving it, it's done already. Do you see that on the horizon that there might be a new car like a Tesla Roadster emerging, but at this moment it's still too expensive, priced out of the market?
Yeah, so we have this hypothesis at Platfora that what we're seeing right now is a real generational shift in the way people use data, and it's not, Hadoop is the enabling technology, but the real shift underlying it is that shift from, like the analogy of like the old way of thinking about a data warehouse was like an organized filing cabinet that I had to spend a year organizing, and then it could only answer the questions that I built it out for. And this data reservoir, data lake approach that Hadoop enables means that I can put my data in its raw form as raw material for the unanticipated questions that are going to come. And I think that is a much more fundamental shift, and we're just beginning to see the repercussions as people move to that way of thinking. That, you know, if you're going to do that, Hadoop is by far the best way to go approach that architecture. So if you think about, well, what could come that would change and be the next thing? Well, for a start, I think that characteristic is the core characteristic. So you know, it's not like anything else. You know, that is the key enabling thing. The second thing is Hadoop is a fertile, evolving thing. You know, Hadoop 2.0 and all the new capabilities mean that on this open storage foundation, there's all these new capabilities and engines that are going to emerge that will move very, very quickly. So to say that there's something that's going to come and replace it is almost hard to fathom kind of how that would be. It'd have to augment in some way rather than replacing, to be real.
Yeah, let me add a couple of things. I mean, obviously, there's no limit to invention, and Hadoop is, you know, I keep telling, my team gets mad at me every time I tell them how sophomoric their code is, right? I mean, Hadoop's got a long way to grow. It's still very young. But it is growing, and it's got a huge community of people contributing to it. So my bet is that Hadoop is going to be with us for a long time, or what Hadoop evolves into will be with us for a long time. So there's looking at it, there's two trends, and I think Ben touched on one of them really well when he brought up Hadoop 2 and Yarn and sort of the way that ecosystem is evolving. I think the Hadoop we use in 5 years will be almost unrecognizable. Right, because I mean, Hadoop now can run NPI, and Hadoop can, we're seeing people contributing. These guys have contributed Kafka. I think that's going to really change how people think about the world, and a number of other interesting open source projects that just become part of that stack, right? So it's evolving very quickly, and I can name there's a whole bunch of open source projects that are complementary with Hadoop that are on my radar and that I watch with a lot of interest. So the Hadoop ecosystem is evolving. There is, I mean, when people say what's going to replace Hadoop, I mean, every year the project, 2 or 3 people have announced that they have a Hadoop killer. And, so far we're continuing to grow. And in fact, a lot of those people are now working in the Hadoop ecosystem, right? But, it's absolutely the case that there's a lot of interest in defending, folks' high margin status quo businesses. So I think we shouldn't be looking for replacements. We should be asking, how do we support the evolution of an open source platform that lets all these things happen on top of it? What we don't want to see is balkanization, which is possible, right? I don't want to see a Unix decade. I'd like to see, a sort of agreement that we're going to all focus on innovating on top of a common open source base that is completely open source, free, and owned by the Apache Foundation. If we can do that, then I think that's going to be a lot more productive than seeing balkanization.
Yeah, so I come from a financial markets background, so where the investment banks have been dealing with big data and real-time analytics for a long time. And then when you say real-time, it's like microseconds, even nanoseconds. Looking at the non-financial companies, there are 2 trends that I'm seeing. Correct me if I'm wrong. One is there's a trend towards going real-time, and then there's cloud computing. To me, it looks like 2 different directions. Am I accurate in that assessment? Or?
I think there are different forces at work there. So one, the super real-time stuff is trading, the wide-speed type stuff that's very specialized for that purpose. There are many different questions in an investment bank. There are many different questions. If you want to ask questions about what trading position should I take at a microsecond level, that's probably a good solution. If you want to ask about risk that may happen at a different time cadence, if you want to ask about relationship or understanding broader market trends, or retail banking opportunities and others, there's all kinds of other things that happen at different time cadences. And so real time, in my mind, is always an optimization on some underlying thing. In the case of some of these very specialized use cases, you understand the use case so tightly that we're already super optimized around that type use case. But when you get back to, like we have a lot of conversations with investment banks around their goals around 360-degree view of a customer, and that they are building data reservoirs and lakes because they want to bridge the silos and they want to get rid of the lack of connective tissue between the different parts of the bank. So these problems exist very fundamentally. Then there may be things that they discover there in terms of processes that they want to provide a real-time view into, or real-time of feedback loop on. Again, that's an optimization on top that they kind of get to.
What I was alluding to was when you move to cloud, you're adding to the latency, especially when you're talking about mobile marketing and all that. Is that like counter in the wrong direction?
I don't think cloud. I think cloud's orthogonal. I mean, you're not going to have you wouldn't design an architecture for trading where you'll have to go through a cloud hop if you're caring about microseconds. But for most other things, the latency of a cloud hop is irrelevant. It's really more a question of where do you want to put your data, where do you want to put your processing. It becomes a cost of bandwidth, cost of storage, cost of processing, infrastructure question, and that just becomes that's where do you put your data centers. I mean, at some level, whether they're internal or externally managed is just a detail.
I think a related question that I hear a lot is, this real time and low latency versus, Hadoop are these batch solutions. And then you have things like Impala and other solutions that are kind of bridging that gap. I think the reality, the expectation most people have when they ask, okay, well, what's frustrating to you as a data scientist? What would you like to see improved as a tool? And they think that the answer is going to be, oh, I need be able to query faster, right? The reality is, I thought that too when I got to LinkedIn. I thought, oh wow, if I have faster ability to query, I'd be able to move faster. The reality is, like, you think about a problem, you issue a query. When you're doing analysis or data science or developing a new product, it's really the speed of thought that I think limits you. It's not really waiting for these long jobs to come back. With Hadoop, a 5-minute latency or 1-minute latency isn't going to make or break your work day, right? You get a cup of coffee, you look at your favorite news site for a second, and you come back. But I think that's maybe a misconception. Now, if you have something where a real-time decision matters, if you're guiding a missile or if you're doing a trade or something like that, then that matters, right? But I think you should think very carefully. Don't spend a lot of money and invest heavily in this. It's kind of like hiring the neurosurgeon to fix your sink, right? Don't do that.
I would just add that if you look at cloud or Hadoop, what you get is agility. You get to your first answer, your first infrastructure very quickly, and that's what sort of blew the doors off at Yahoo with Hadoop. Was we had scientists who were literally spending 6 months to get a question answered, because step one was start a procurement conversation with IT, right? And they moved to the point where they were able to answer questions in a day, or a week, or in an hour, depending, right? And so, people will look at that and say, oh my goodness, a query takes an hour. Well, it's okay, yes, but that particular query was unanswerable before without, an infrastructure investment. So I think you got to think in terms of sort of different life cycles, right? So there's an innovation life cycle. How fast can we prove an idea? And what we built with Hadoop at Yahoo was, and we see other people building with cloud and other technologies, is a low-cost engine to prove ideas quickly, right? The advantage of cloud is you can stand up your startup without, building a data center. Find out if your idea is going to sell and then scale it up. So when you get to that validated hypothesis and you need to figure out how to, now deploy that technology in a serious business way, then you got to look at your tech stack and figure out what's appropriate. But in cloud and Hadoop and all these technologies may or may not be appropriate for that different life cycle. But think about the whole life cycle of innovation, not just the finished product, I guess would be what I'd say.
Peter, let me ask you at LinkedIn, what are the problems in big data that you guys have not solved yet that you really want to solve?
I think if I told you that, it would give away some competitive advantage. So the
small group here.
So the problems in big data that we haven't solved yet that we think are, well, I think some of the stuff you have on the board there, I think there's some really interesting open areas that are at this boundary of when you're doing these batch processing systems, when you're using those to solve machine learning problems, you do hit these weird hybrids situations where certain algorithms need to have things in memory and then also deal with large amounts of data that can't be in memory, right? And I think that kind of creates this impedance mismatch in engineering when you try to implement some of these algorithms. And specifically, you may want to store a lot of that state and store a lot of that information and do a lot of these iterations. So I think that's an area where machine learning on big data has still got training wheels at this point, where you've implemented a lot of the algorithms that are easily dividable or parallelizable, and then you've got this friction of, okay, well, how do I had an intern last summer work on large-scale topic modeling in MapReduce, right? And there's an open source version of that code, and it's hierarchical topical modeling. So it's this pretty esoteric stuff, I guess, for most folks, but that's really where the kernel of some amazing stuff is going to happen in the next, I think, 10 years. And Google has all this great work going on in deep learning, and that's fascinating, and that's really emulating in a way what the brain is doing and learning from unlabeled data. So this kind of unsupervised and supervised mixture is going to be, I think, huge, and it's pretty unsolved right now. If I have to gather training data for a machine learning algorithm and label, okay, is there a cat in this picture or not? That's pretty easy to gather training data. But if I have all these, more difficult questions, like is this guy an expert in Hadoop? How do you gather, 10,000, 20,000, 100,000 examples of that kind of evaluation at scale and at low cost, right? So the answer is probably you can't at this stage. So you have to be able to use unlabeled data and use some unsupervised techniques.
I always love the question of one of those prospective customers who are on the couch still, so to speak. I want software that'll just tell me all the interesting things in my data. Show me what I need to know, it's a funny thing. I think that, in limited ways we may actually, not us, the industry may get there over time, but it's, in a general sense without, obviously having a super brain just looking at the data and figuring it out, there's no obvious answer, but it's interesting.
Well, to that point, where do each of you guys think this industry will be 10 and 20 years from now?
EJ, you want to start?
Wow. 20 years ago, big data was here. Financial services, I think one of the things that I was very fortunate to grow up around was a lot of the people that were working on AI back in the 80s, 70s and 80s. So I got a lot of exposure at that time to people who were trying to do that work. I think what we're going to see this time that's different, and I think we're also at a very risk of this, is that we have hyped this up so much that it's like, how can we meet that expectation? Because the technology is just not, we're just not there yet to meet it. We're racing hard, and there's a lot of great stuff coming. But I think at the same time, we have to also be realistic in what we can achieve. I think there's tremendous promise in the healthcare space, and I think if we get some real significant wins there, we'll start seeing added value. The thing that I'm most excited about is the energy of the people who are coming just straight out of school, who are building things in all sorts of sectors. Code for America, where people are trying to change the government. We have people around the world who've been excited by things. And I think they're going to craft and take this in their own direction. And just even labeling this data scientists and sort of the whole data science phenomena, I think is more of a recognition of the community saying, hey, we didn't have quite the right label. There was no intent to actually label it. It's just more that the community decided that, hey, this seems like a good way to call it. In that same way, I think we're going to see over the next 20 years, I would be very disappointed if we don't see 3 total complete evolutions of the system and how we think about what we can do and what's happening. And I'd say we're at one of or phase 2 since the 80s right now, and we got to increase the cadence of that evolutionary time period.
I mean, 10, 20 years. This is we're getting into speculative singularity type points of time here. I mean, I think that there, to my earlier comment a moment ago, I do think that there's this beginning of an emergence of, like today there's so much data, at some level you're collecting this data and you can only make meaning out of so much of it. At some level, humans are the limiting factor to be able to sort of decipher what's there. Even the algorithms we create are only the first layer of being able to sort of decipher meaning. I do think that in some ways we start to elevate it. It's almost like the meaning emerges from the data. The data becomes aware of its meaning in a sense, and you start to have sort of emergent AI type things where you can ask questions and reason about data at high levels of abstraction. I mean, it's very, very hand wavy, but I do think you start to get, sort of, some of this work, there's companies like Numenta looking at sort of neocortex type, and then looking at that for doing sort of prediction, understanding sort of some of the sort of the biological AI principles and how they tie in. I do think that this world starts to become very fused over that time period, and we start to look at new types of intelligent processing that kind of emerge.
That's great.
Who was it that said that we tend to underestimate We overestimate technological progress in the short term and underestimate the long term. One of the sci-fi authors. Asimov said that? Thank you. So, I mean, I think in the short term, yeah, this is really a hype space. And when people come to me and say, you know, I want to discover the value in my data, I kind of cringe, right? I'm a plumber, right? I know how to collect things, and you know, I like more concrete problems than that. But so I think in the short term, yeah, and I think there's a lot of expectations that this is going to just transform everything overnight. It's not. It's hard work. There's a lot of things we need to work on. But if I look at the trends medium term, it's just kind of mind blowing, right? I mean, I was talking to some of the guys at Slack at this linear accelerator who are looking at some of the star problems. And they were trying to figure out how to build indexes to serve to the public a 10 petabyte database that was going to be online in 5 years or so. And you know, I was looking at that and I'm like, well, you're looking backwards here, right? A 5 petabyte database is going to be like a spreadsheet, right? Just put it on Amazon and let people, you know, pull out their credit card and process it.
On the mobile phone. On their mobile phone.
That's right. Right, that's right. Download it to your phone. I mean, so I think, you know, there's really some fascinating trends. I think the one that really interests me is that, you know, we're going to be retaining so much more about everything, including our own lives. So you look at this, we're all walking around with an incredible array of sensors right now. So, and we're going to be applying that data in ways we haven't really thought of yet to really revolutionize, you know, everything from how we schedule appointments and how we travel through the city to, you know, our healthcare and everything else. So I'm really excited about that confluence of sensors and retained data and new algorithms and science on top of it.
Yeah, I'll agree with the other panelists here. The prediction is hard, especially when it's about the future, right? Niels Bohr said that. But if I were to look ahead, I think, you know, just follow the trend line of what I've been seeing happen. I think what you're seeing now is the convergence of a few things. So you had all these great statistical techniques and the AI stuff that DJ mentioned, which really couldn't take off earlier because the tech wasn't there to support it, right? So these algorithms couldn't run you know, beyond toy problems, right? Now you've got that scale, you've got the equipment where these big guys in the valley who have all the talent and have the resources can, you know, the Googles and Facebooks, LinkedIn's can apply these algorithms at scale to revolutionize, you know, different industries and verticals. I think the first phase you'll probably see is kind of a repeat of that in other verticals, like you mentioned earlier. So it may not be the high barrier to entry ones at first, but I think you'll start to see these like nearby neighbor sales, marketing. You'll see these other industries. You'll see a LinkedIn in sales or in marketing or something like that. That will revolutionize an industry and change the way that you do business. I think the other trend that you mentioned is around all this data that's being logged, that people realize there's value, and there are all these pennies that they're dropping and not picking up. People will be picking those up, logging everything. And the trend I think what we'll see there is, in this a little bit longer term, is there's this thing called augmented chess, right? So they have these competitions. It used to be Big Blue versus the human, and you'd have these challenges. Now they have humans working with computers, competing with other humans working with computers, and they can beat either the computer or the human working alone, right? And I think that is what is going to happen. In the future, it looks more like RoboCop, right, instead of Terminator, right? So you're going to be these hybrid. You're going to have all these apps and devices that you couldn't live without, right? Like I took an Uber here this morning. If I didn't have Uber, I'd have to figure out how to call a cab. I don't remember how to do that. But you know, like dial that 10 years down the road, and it's going to be you're going to be you know, embedded in this this ecosystem. Your social network, your work, your employer, all the way that you do your job is going to be embedded in these algorithms and devices.
Great. Let's hit some of these real quick. Performance bottlenecks.
Every part.
Okay, next item.
Anything particular performance bottlenecks?
Yeah, well, I mean, it varies tremendously, but I would say one thing that's really interesting coming down the road is sort of like the new processors and things like that, but nobody's designed those, put those in a package for big data yet, right? It's like, it's great to have, you know, ARM processors, but if you put a network with 1/10 the bandwidth of the disks between your processor and your disks, you don't have a big data solution. So that's one. How do we get the data off disk to the CPU fast enough? And then, you know, obviously cost-effective networks are an area where there's lots of room for innovation.
How about data governance? Any comments on that?
You know, I think we hear a lot of people asking about, I want to build this data reservoir or a lake, but there's all this, I can't just throw this data together and have a free-for-all. You know, maybe Facebook can do that, but if I'm a bank or a healthcare company, I can't. So then there's a lot of questions about, let's say, first of all, security, who can see what, and then data lineage. If I build some product based on some underlying data sets, understand what were the path of things that went into that result, so I can actually have visibility up and down the stream, and then kind of governance in terms of any lifecycle processes and retention rules and so on. So I think it's an essential part, and you know, not as glamorous, but if you don't have some of these enabling pieces, it just stops that wider enterprise deployment.
One of the things I think is very important to think about data governance is there's two sides of data governance. There's the internal aspects, like the classic SOX, PCI, these type of things, who has access to what data. But there's also data governance that we're seeing from the other side, which is external governance, and the almost what you could call data ethics as well. Should you actually put these data elements together or do these things? And we're about to see a very rough ride ahead, given a bunch of the things that have happened, both in security space, but also we're seeing people are saying, hey, you know what, I have a bunch of data about my users, I'm gonna go sell it. Probably kind of a stupid thing to do, right? Because at the same point, it's like, well, whose data is that? And how are you packaging it up as a value, and you're just abusing me and not giving me a cut? And then at the same time, like, you know, AT&T or something, you're like, well, you guys are already crushing me on these costs. You're being jerks when I call, and then you want to sell my data? Yeah, we know exactly how we're going to react to that. So I think there's this other side of that data governance that's going to be a hammer that's going to drop, and if the organizations aren't careful about how they think about governance of their data with respect to other parties, which typically tends to be marketing, there's going to be a knee-jerk reaction across, like we saw with the EU about 5 years ago with respect to privacy.
Well, I totally agree. There is so Mark Andreessen talks about the free ice cream principle, and this is more around privacy, but I think it relates to this as well. The idea that, you know, everybody likes free ice cream, and you know, if the cost of, you know, the cost of using Facebook is you give a little bit of information up, you know, the benefits are so good. It's a slippery slope at every point in the technology cycle. The benefits of the new thing are just good enough to justify giving up a little bit more. And then the line keeps moving, and you know that you can say whether that's good or bad, but the reality is you try to start a business that bets on people wanting privacy or more, like if you try to start a Facebook that has really, really good privacy controls, nobody's going to use it because that's not where the friends are. So you know, part of that is you can project forward that at some level the norms will change, and people will just may be comfortable with all this data being out there, and it's interesting to see where this thing evolves to over time.
How about the evolution of the data warehouse?
Data warehouse is dead. No, I mean, in real terms, I think it is, the traditional enterprise data warehouse is a legacy architecture. I think it is already. Like people build it reluctantly. They still invest in this technology, but for the most part, I see very, very few people saying, I want to go start a new data warehousing project because they know that they're locking themselves in for a ride, or very expensive, pre-canned all the questions they want to answer, and they kind of know that's not the right answer. The trouble is the other alternative is not fully baked yet, so they're living in a little bit of an intermediate state, and we play a role in helping there. But I don't think people increasingly don't want to be betting their careers on yesterday's approach.
I'll chime in there. I think it's been interesting for me. I used to actually be a database consultant way back in the previous life, and doing Oracle PL SQL stuff. And so I've seen this evolution and a move away from that. So I see that happening. I think there's a new problem emerging which is related to when you start collecting all this data and put it in this massive pool. It's not all exactly in the same format, not the same. It'd be nice if it would be bad from a performance standpoint, but it would be nice from a user standpoint if they're all kind of like text files you could just read and understand. But it's not. So I think we use Avro. We did a big project convert over. Avro is a key part of Hadoop now and the Apache Foundation. But we use that as a data format. And when you have new data elements that are not in that format, and it makes it difficult because people will put like a binary in the file somewhere and it's hard to disentangle and you have to find the guy who knows it. So that's the old school problem of finding the guy in the company. It's now happening, but it's in that data pool.
Yeah. So on the data warehouse, I mean, this is the first year that Epsidic has actually showed up in my day-to-day work life, right? So the mainframe isn't dead yet. Right, so we predicted that in the 80s. So I think the data warehouse is going to be with us for a long, long, long time. It's in a lot of uses, adding a lot of value, which isn't to say that there won't be a lot more value created nearby, right? But I think there's lots of opportunity mining those seams and figuring out how to effectively move data back and forth and let people do the jobs they understand in the old context using new tools and using, there's people trained on all those tools. How can we make them more effective? I think is a really big opportunity. Then the other governance, data governance is I think a huge opportunity because it's just every organization is trying to figure out how to retain all this data and how do you manage it, how do you anonymize it, how do you open it up for sharing without destroying your business. Is just a huge set of challenges and opportunities, I think, for clever innovation.
SQL versus non-SQL?
There's plenty of Quora posts on that. And religious wars have been started over less.
I think at some level it feels like that was an argument. That was an argument. I feel like that's an old argument. At some level, it's a false argument. Even there, whether you have a SQL query interface in or not. I mean, use the right tool for the right purpose, and it's not like a lot of those things that didn't have SQL interfaces are adding SQL interfaces. So it's not like there's this chasm of divide, and the old the new stuff is not disrupting the old stuff. They're just different tools for different purposes.
It's an and, not a versus.
Yeah, we have a lot of people that come to us who want solutions who speak SQL, and we're helping them do that. And there's lots of people who have new problems they want to cast in other ways, and we're helping them do that too.
How about data security?
Yeah, so one of the ones that I think is the biggest thing that people have to shift the paradigm over, everyone's been very focused on building higher and higher castle walls around data. At this point, you have to assume the assassin is inside the castle. And if you're not thinking that way, and you're not trying to track and figure out what's happening inside your system, you're just deluding yourself.
I think it is that double-edged thing. So counterpoint, the controlling what you can access and making it possible to actually do productive work, two sides of the same coin. So a lot of the challenge is you can build these. So there's things like a Cumulo, which is this very high security thing similar to HBase, but a way of doing very fine-grained transactions. It has good use cases, but you can easily build something that's so complex that you can't actually get much work done, and then you end up bypassing a lot of the protections because you need to get work done and you sort of defeated the purpose. I think a lot of it is how can you find that right balance and allow, when you make a policy decision that you want to connect some data up, you can do that easily and you haven't forced yourself into a world where you've recreated all the silos.
Yeah, I would agree that the challenge is you need both, right? You need productivity, you need security. They certainly seem to be in conflict. Is there an opportunity for more innovation to help, right? I would think in general, there's no such thing as the perfect policy because you can't lock up the data, and so I think it's much more around monitoring and detection and and human policy issues, which are always the tough one for organizations. Right.
I would say coming from a defense background, this is something people have been thinking about for a long time, and I agree. I think that's the answer: is kind of careful monitoring and internal controls. And I think Hadoop, by instrumenting things more, that's actually enabled to a high degree. So with like Hadoop, you can see down at the level of an individual query, what tables are accessed, what rows, what data, and logging that data and making it available and analyzing it with Hadoop itself. You can actually figure out what's going on and what's unusual or anomalous.
One last note, one of the most interesting questions we get around this is, it's pretty easy to decide for a single record who can read that, who should be able to access that record. It gets much thornier when you start to look at data in aggregates, and you start looking at models of behavior and all the downstream kind of products of that. And I think that nobody has a good answer for that. And I think that's something which, as more and more of these as you build these layers of downstream products, how do you reason about what you should be able to access is sort of unsolved.
Isn't the bigger issue around security preventing damage rather than access?
What do you mean by damage?
You change the information.
I think generally,
or you remove it, or
I think in these kind of contexts, I think in a transactional system that may be true. When you look at the analytical side, most of the stuff is sort of append-only, large log records, where just even touching a file will change a file stamp that says something weird happened. So it's not easy to go do that. I think the bigger issue is really this data is stored so redundantly in enough volume that it's really more the risk that it leaks, people use it for the wrong purpose, or those kinds of risks than somebody deleting it or stealing it or deleting it or modifying it.
Yeah, I would just say the challenge is it's a nuanced problem, and I've seen tremendous amount of resources wasted to achieve sort of checkbox items in this area. And so the trick is to do the organizational design and the policy design to allow productivity and risk mitigation, because there are real risks of all kinds, right? Including the kinds you enumerated for sure.
Last item up here is boundaries. Not sure I remember the context.
That was over the yellow.
Oh, was it? Okay. All right, let's take a couple more questions and then we'll wrap it up.
As we understood, Hadoop and big data, the tools to run Hadoop and all these things seem to be resembling the way human beings eventually created silicon chips. Using silicon chips to embed everywhere so we can build custom systems to do more useful work, and just using the chip as paperweight for decoration purposes. Right? So do you see that eventually this big data industry will evolve into like a chip industry that providing ready to go type of packages so that people can add value easily?
I think in this industry, broadly, high-tech industry is all about raising levels of abstraction. You build chips and operating systems and layers and layers and layers and layers, and this is another layer that you build on as a platform for other things. And so in that sense, I think abstractly, yes, and that it's a platform and that there may be ways that it gets packaged into other solutions. But I think that's not new in the industry, and there's many, many, many examples of that class of phenomenon.
Yeah, the best example of that, especially the silicon example, is the shift that happened from to fabless semicon production. So it's the stuff that was done by Cirrus Logic and other companies at that time. What I think dramatically is different with silicon is it's a commodity component that's then put into stuff, and then, for example, the ASIC layer has not taken off like we thought it would. What is this data is that you're using it in many rich application layers to enhance other products. So take, for example, the Nest in your house.
I would just add that the key to Hadoop is sort of scale out low-cost commodities. So Hadoop is really, when we talk about designing large-scale Hadoop clusters, we really focus on selecting commodity components. But of course, the interesting thing is now there's enough Hadoop being deployed that it's starting to drive commodity component design. So it'll be really interesting to see, what happens, because there's certainly things we'd like to see in commodity computers, lower power cost, and more efficient architectures. But it has you gotta look at sort of, I'd say people buy Hadoop systems for the price of the data at rest, right? If it's really, so a lot of times people try to give us a faster computer, and it's like, well, if you've made it more expensive, you're not necessarily helping, right? So, but yes, I think that Hadoop is starting to drive what the next commodity computer of the future will be, and that's interesting.
So I think we've reached the end of our time. So thank you to the panelists. I think you guys did a great job.